Okay, so on this skill sheet, we talked about density, and we said that density was this mass to volume relationship, and it's actually this ratio such that density equals mass over volume, or density equals mass divided by volume. Really quickly, we can also isolate the variables such that mass would then equal volume times density, and we could also state that volume would equal mass divided by density. So there's maybe three ways to represent these density equations. Further, density is this intensive property, which means the amount does not affect the value. A good example of this, if I found a little aluminum nail and tested the density, and I obtained it to be 2.7 grams per milliliter, if I had a piece of aluminum foil that was twice as massive, the density would still be 2.7 grams per milliliter. Although the mass is twice as large, that means the volume would also be twice as large. So this ratio, this mass to volume relationship would stay the same. It means that density is a nice way to maybe test the identity of an object. If you find a coin you think it might be gold, go test the density and see if it equals that of gold. Finally, I talked about buoyancy today, and buoyancy just kind of refers to the fact that less dense objects float. And conversely, we could say that more dense objects would sink. So maybe a little picture to represent buoyancy. If I filled a graduated cylinder with two liquids, liquid 1 and liquid 2, and this little mystery object in it, the mystery object kind of floated above liquid 1 and beneath liquid 2, I guess we could say that liquid 1 is the most dense of the three substances in the graduated cylinder. The solid object is in between, and then liquid 2 would be the less dense of the three objects. Okay, now let's practice some of these calculations. For practice 1 here, what is the mass of an object? So we're looking for mass with a volume of 250 milliliters and a density of 0.72 grams per milliliter. I think it's nice to always pay attention to these units and notice that we're dealing with milliliters in both places here. That's good because they have to match. So earlier we stated that, let's look, okay, mass equals volume times density. We can set up mass equals volume times density. Oops, can I get off the screen there? So I could say 250 milliliters times 0.72 grams per milliliter. Now I go and enter that on my calculator, and I get 180 on my calculator, and I think we want to always consider significant figures. So we were multiplying here, so let's think about how many we have in our values and then go with the least. So there's no decimal place here in 250, so I start counting from the right. I wait till I get to my first value, and we got 1, 2. Now in the value 0.72, I have 1, 2. Since we have 2 and 2, let's go with 2 in our final answer and just stick with 180. And what unit? Well, milliliters cancel. I guess we're left with grams. Okay, now second one, what is the volume? So we're looking for volume. So volume equals mass divided by density. Now let's check out these units again. What is the volume of a 30 kilogram gold brick? And gold has a density of 19.3 grams per milliliter. I think it actually might be 17.3, but we'll go with 19.3. So I notice now grams and kilograms, these units do not match, and that is not okay to use this in a calculation. I need to convert one of the two. I'm going to remember that the unit or the prefix kilo refers to 1,000. So I actually have 30,000 grams of gold and divide that by the density. Now the calculator says something around 1554, but when we look at these values at the beginning here, 30 only has one significant figure, so that means we should round this all the way up to 2,000. So I guess a 2-liter brick is going to have a mass of 30 kilograms. So in the movies, you see these people throwing around these gold bars. You know, this 30 kilograms would be this 70-ish pound gold brick. People aren't really just throwing that around and throwing them in their backpacks and running around with 8 of those. Question 3. I found a coin that has a mass of 10.2 grams and a volume of 1.2 milliliters. Using the table below, what is the most likely choice for the identity of the coin? Now, if you want to try and find the identity of something, we can maybe compare the densities. So let's go ahead and calculate the density. So density is going to be mass divided by volume, 10.2 grams divided by 1.2 milliliters. We enter that in calculator, and then we consider sig figs. I got 3 and 2. Let's get 2 in our answer. So we got 8.5 grams per milliliter. So if you had to pick, I would say nickel is the identity of this coin. It's the closest to the 8.5. For question 4, what would happen if a bar of solid silver, which is 10.5 grams per milliliter density, was placed in a pool of mercury? And if you don't remember, mercury is this liquid metal. So if we kind of imagine that we have this pool of liquid mercury, which has a density of 13.5 grams per milliliter, and then when we look at the density of silver, 10.5, it is less than the mercury, so that bar of silver would actually float on top of the pool of mercury, and that's as long as they don't mix. Kind of crazy, but it would float in this situation. Let's try a couple of the practice 2s just because we're here. Let's kind of expand on what we've been practicing. So question 1 is, what is the density of a wooden beam with dimensions of 1 meter, 1.0 meters times 8 centimeters times 8 centimeters, and has a mass of 14 kilograms? And then further it asks, would this beam float or sink in water? So first off, let's find that density. I'm going to get these all into the same unit. So I'm going to go ahead and change my 1 meter. I'm going to do the volume up here. So that would be 100 centimeters times 8 centimeters times 8 centimeters. 2 sig figs, 2 sig figs, 2 sig figs. Let's get 2 in our answer. So I guess it's going to be 6,400 cubic centimeters. Remember, that's also equal to 1 milliliter. Okay, now the mass, 14 kilograms. I'm just going to go ahead and turn that into grams so I can answer the floating question later. That's going to be 14,000 grams because there are 1,000 grams in 1 kilogram. So my density will now equal mass divided by volume, or 14,000 grams per 6,400 centimeters cubed, which is the definition of a milliliter. So I'm just going to change that to milliliters right now. So let's divide these two, and we get 2.1 grams per milliliter when we look at the 2 sig figs used in all of our calculations. So I would now have to look up the density of water, and it is 1 gram per milliliter. This nice easy number to remember. So since this wooden beam is actually more dense than the water, this must be maybe not a typical type of wood, but I guess this type of wood would sink because it is more dense than the liquid it is placed in. Question 2. I found a spoon with a mass of 29.4 grams and a volume of 2.9 milliliters. Is my spoon made of silver? Again, to maybe think about the identity of this object, we could consider the density, and the density of silver is about 10.5. We saw that in this table over here. So let's go ahead and calculate the density. So the density of my silver will be the mass divided by the volume, or the mass of the spoon. 29.4 grams divided by 2.9 milliliters, and we get 10.1 grams per milliliter. So this is where I really want to encourage you to answer and then back it up. So I think you could say, yes, this is made of silver because it's close enough to silver. It's only off by that last little estimated digit. I think you could also say, no, we performed our measurements fairly carefully, and we think it's too far away. If you said no because the density is too far away, I think that's also a strong answer. I'd probably go with this for this little series of data, though. Okay, for this last little practice 2, really think about what is density. So draw a graph plotting the mass and volume for a liquid with a density of 0.5 grams per milliliter. So I want you to think about in math, what is rise divided by run? Think about that for a sec. I think in math we say rise divided by run is the slope. And if we look at that, the rise is the mass and the run is the volume. Oh, look at that. The slope equals the density. So if we imagine a perfect 1-to-1 ratio, it might look like this. So an object with a density of 1 like water, if we're talking about grams and milliliters, would look like the dotted line. So something with a density of 0.5 grams per milliliter, probably be right around there. Okay, I hope this helped.